Well, welcome to 3.3. We're going to be multiplying in this section using fractions. And we'll start out with one to give you sort of a visual. This is your gas tank holds 12 gallons of gas. And the gas gauge in your car reads three-quarters full. How many gallons of gas are in your gas tank? So I'm going to do this with number lines using lines for a tank, an entire tank of gas, gallons, and force, because that's the other measurement we have. So try to create some kind of a straight line. There is a tank, and there's one tank. And here are gallons. And one tank is the same as 12 gallons. And then I'm going to use force. 1, 2, 3, 4 force. And recall that 4 force is 1 whole. So are 12 gallons of gas the whole, the part, or part of the whole? Well, one tank is 12 gallons is 4 force. It is the whole. So what I'm going to wind up doing here is 12 gallons I have, and I only have 3 force. So if I take 12 and divide it by 4, which is the same thing as 12 times 1/4, I get 3. So 1/4 of a tank is 3 gallons. So from here it should be pretty easy to see. If I double the force, I would double the gallons. And if I triple the force, I would triple the gallons. And I can write this up here. There's 1/4, 2/4 of a gallon, 3/4 of a tank, and 4/4 of a tank. So doing it visually, you can get a visual idea that the answer is truly 9/12. So I found 1/4, and now, which is 3, I'm going to multiply the 3 gallons by 3/4, and I get 9 gallons. So that's a long way of doing it, but it's just to get some visual here. In one expression, it would be 12 times 3/4, which involves a combination of division, 12 divided by 4 is 3, and multiplication. 3 times 3 is 9. So when doing problems involving a whole number and a fraction, I'm going to get, if I want less than the whole of this, I should get a smaller number, which I do. And it involves a combination of division and multiplication. So I'm just going to give you 2 examples here. This is just 2 examples of 2 multiplication problems involving fractions. I'm going to do this one a little bit differently than you might do it in the future, but just to do it this way. So this is, of means multiply. So I want 2/5 of 25/12. And I can write this out as the unit, because it is the unit. So here this is a combination of multiplication and division. It's easier to divide first. 25 divided by 5 is 5. 5 times 2 is 10. So this is 10/12. Or I can write it 10/12. I can reduce this by recognizing they have a common factor of a 2. So this would be 2 times 5. And this would be 2 times 6. 2 divided by 2 is 1, so it cancels. Because 1 times any number is itself, and reduced it's 5/6. So that's the way you can do it. And here is 2/5 times 25. And again, it's a combination of division and multiplication. 25 divided by 5 is 5. 5 times 2 is 10. Okay, so just follow the logic here. There will be an easier way to do this, but the logic will lead to that easier way. So here you have 2/3 of a container of yogurt, and you want to divide it evenly into fourths for 4 servings. So in this case, 2/3 of the container is 4/4. So what I want is 1/4 of, which means multiply, 2/3. I'm going to write it like this. So notice, by the way we did it last time, I could divide 2 divided into 4, but 2 doesn't divide into 4. If I had an 8 here, 8 divided by 4 is 2. I could do that, but I have a 2. So I'm going to take 2/3 and change it into a new fraction that's equal to, with the numerator of 8. So I'm going to multiply the 2 by 4 and the 3 by 4, and I get 8/12. So now I have 1/4 of, which means multiply, 8/12. Now it's a combination of division and multiplication. 8 divided by 4 is 2. 2 times 1 is 2. So I get 2/12, or 2/12 this way. So 1/4 of 2/3 is, right here, 2/12. Now let's look at what actually happened here. 1/4 of 2/3. It appears we can just multiply straight across the numerator and straight across the denominator. So that gives us a real shortcut instead of doing what we did here. So we're just going to utilize what we just learned, right? So you have 2/3 of a container of yogurt, and you wish to put 3/4 of what you have in your lunch. How much of the container goes into your lunch? Well, here I want 3/4 of 2/3. So I can just write this also, and you would write it as 3/4 times 2/3. And from what we just learned, when we're multiplying a fraction and a fraction, you can multiply straight across. And you would get 6/12. And you can also reduce this, because this is 1 times 6, and this is 2 times 6. 6 divided by 6 is 1. So you're putting in 1/2 of the container. If you take 3/4 of 2/3, you get 1/2. And for a little bit more advanced way of looking at this, you could divide 3 divided by, you could cross reduce. 3 divided by 3 is 1/1. 2 divided by 4 is 1/2. 1 times 1 is 1, and 2 times 1 is 2. So you could reduce this before you multiply. But the bottom line is, when you're multiplying two fractions, you multiply the numerators straight across, and you multiply the denominators. This is a very different kind of problem that involves multiplication. A lot of students, they mess up on these, so it's not that hard if you can visualize it. We're going to use number lines just to visualize it. So you need hay for your alpacas. A trailer currently contains 14 bales of hay and is 2/3 full. How many bales of hay does a trailer hold when full? Well, if it holds 14 bales of hay and it's 2/3 full, there's more hay that you can put on the trailer to make it 3/3 or the whole is filled. So the number lines I'm going to use are the trailer, hay bales, and I have thirds. So here is one trailer. And that one trailer, we don't know how many bales of hay it holds. And this will be in thirds. 1, 2, 3 thirds. So we know that 2/3 is 14 bales of hay. But we want to find out how much the trailer holds, and the trailer holds 3/3. So just writing down what we have now, we have 14 bales is 2/3 full. Right here. Now it is really pretty easy to go back and see, well then if I divide by 2, I find out what 1/3 is. And I get 7 bales. So 1/3 is 7 bales. And now if I multiply by 3, I get 3/3 and 21 bales. Now let's see how I do this mathematically in one expression. I have 14 bales and I need to find out how much the trailer holds. So what I did is I divided by 2 and then multiplied by 3. 14 divided by 2 is 7. 7 times 3 is 21. So notice what I did there. In one expression, you could do it this way. You could load it up, take your time, and do it with number lines. But if you can see this, it's certainly the simplest way. I just used the reciprocal in the last problem, so we're going to define what the reciprocal is. The reciprocal is the number that you multiply by. Given the number, I'm given 3 numbers here, it's the number that you multiply by in order to get 1. So it's really simple to find. You just flip the number 5/4. The reciprocal of 4/5 is 5/4 because 4/5 times 5/4 is 1. And how do I know that? Right? Should be obvious, but you multiply straight across the numerators and the denominators. So I get 20 over 20. 20 over 20 is 1. So now I have a negative 7/10. And watch this. I'm going to multiply by a negative 10/7. Why? Because a negative times a negative is a positive. And then that's 70 over 70, which is 1. And here I have a negative 8. What do I multiply it by? Well, don't forget, you can always put a 1 under the 8, because 8 divided by 1 is 8. I'm going to multiply this by a negative 1/8. Negative times a negative is a positive, and again, I get 1. So these are the reciprocals of these numbers. Well, there's little 2 examples to show you nothing more than algebra is just a generalization of basic arithmetic. So I'm going to use here, I could do this problem, negative 5, 6 times x equals 7, divide both sides by a negative 5/6. But then I get this, right? Just kind of messy. So instead I'm going to use the reciprocal. So here's my negative 5/6 times x equals 7. So I'm going to use the reciprocal. So I'm going to multiply this side by a negative 6/5. Again, a negative times a negative is a positive. And so I multiply this side by a negative 6/5. So these cancel, right? This is 1. So I get x equals, and how do I multiply this? Well, if you need to do this, go ahead. You multiply straight across. So I get negative 42 over 5. If you want to make it a mixed number, nobody said you had to, that would be 42 divided by 5 is 8, negative 8, and 2/5 left over. Remember, a positive times a negative is a negative. So now let's do this one. I have 7/10 x plus 3 equals 5. Now I could immediately multiply both sides by 10/7. That's the reciprocal of 7/10, but then I'd have to multiply both of these terms by 10/7. I don't want to really have to do that. It's easier to subtract the 3 first. Then I get 7/10 times x equals 2. Now I can multiply both sides by the reciprocal of 7/10, which is 10/7, and multiply this by 10/7. This whole thing is 1. So I just have x equals 2 times 10 is 20, 1 times 7 is 7. If you want to make it a mixed number, it would be 2 and 6/7. So I will post a video of all the answers, but just to get you going a little bit, we did this problem almost identical to this. You have an oil container holds 16 ounces, so that's one container, 16 ounces. And you wish to pour 3/4 into your engine. So one container is 4 16 ounces. The easiest way, you say 4/4 divided by 4 is 1/4. So 16 divided by 4 is 4. 2/4 is twice 4, 8 ounces. 3/4 is 3 times. And so that is the number line to give you a visual. To do it just in 2 steps, 3/4, 16 times 3/4. 16 divided by 4 is 4. 4 times 3 is 12. Now you could multiply straight across, but then you're going to have to wind up reducing. So the gas gauge under propane reads 40% or 2/5 full. 2/5 is the same as 40%. If your propane holds 500 gallons, how much propane is in your tank? Well, it's 2/5 of 45. And you should be able to handle that, right? So this one is a little differently, right? You have 120 gallons of water in your hot tub, and it's 3/5 full. How many gallons will it take to fill your hot tub? Now here is number line for hot tubs, gallons, and fifths, because they are what is in the problem. So 3/5 is 120 gallons. So I can't go directly from 3/5 to 5/5, but what I can do is say, okay, if that's 3/5, if I divide by 3, I'm going to put that down here. If I divide by 3, 3/5 divided by 3 is 1/5. And 120 divided by 3 is 40. Now I can multiply by 5. 1/5 times 5 is 5/5. And 40 times 5 is 200. And that's what I did mathematically. I essentially multiply by the inverse, the reciprocal of 3/5. Each blueberry bush this year produced an average of 10 pounds of blueberries. This is about 5/8 of their normal production. How many pounds do they normally produce? This problem is identical to this problem. And just FYI here, the answer would be 16 pounds. So make sure you can get that. If you can't, watch the review, homework review 3.3. So you have 7/8 of a gallon of maple syrup and wish to divide it evenly into 3 containers. And remember, this 7/8 divided into thirds divided by 3 is the same as 1/3 of 7/8. And of means multiply. So if you got 7/24, you would be correct. Divide 3.5 cords of wood equally among 5 neighbors. Well, you're not going to, this is 3.5 divided by 5 is complicated, right? Dividing by 5 is the same as multiplying by 1/5, but you want to change this first into a fraction, which would be 3 times 2 is 6 plus 1 is 7/2. So you really want 1/5 of 7/2. These you should be able to do without much difficulty. I'm going to do this one here for you a little bit. 3 times, I'll put it in parentheses, 2 plus 2/3. And that's knowing how numbers are put together. And then using the distributive property, 3 times 2 is 6. Plus 3 times 2/3 is the 3 divided by 3 is 1. 1 times 2 is 2, and that's 8. Let me do that one again. 3 times 2/3. You could also do it this way. 3 times 2/3, multiply straight across, and you get 6 divided by 3, which again is 2. These you can multiply straight across. This one here just means 3/4 times 3/4. Multiply straight across. That's multiplying straight across or reducing first. And in these two, you want to use the reciprocal. And this one, you want to subtract 4 first before you use the reciprocal.